record. Okay, so we have how many questions? 1, 2, 3, 4. We have 5 questions. Okay, so I'm going to go through 5 questions, and please ask me questions. If you don't give me feedback, I just assume that you all understand, right? So if you want to learn, then better learn from me, right? Since I'm here. So don't be shy, okay? Ask me questions. So the first question is that you will receive 10 annual payments of $22,000. So the first payment will be received 3 years from today. And the interest rate is 5%. What is the value of the payment today? Okay, so you are anticipating future payments, right? So the question here is asking, okay, so what's the value of the future payment in today's value, right? So you are actually calculating a present value, okay? So normally when I approach to this kind of questions, I like to draw a timeline, okay? I like to draw a timeline. So this is the one I draw for this question, okay? So you can see that at this time point is now, okay? And then they were saying that the first payment will be received 3 years from today, okay? So I counted, okay, year 1, year 2, year 3. So right away, the first red mark here, that representing that the first payment, okay, is the 3 years from today, right? And then how many payments do I have? They will receive 10 annual payments of $2,000. So then I will count 1, 2, 3 until 10, right? So this is annual payment, okay? And I also learned that the interest rate is 5%. This is the annual interest rate, okay? So with all this information, okay, we want to know what's the value of the payment today. So what's the value of payment today? So this, the value today, this tells me like we are calculating present value, okay? Okay, so now let's take a look. The cash flow, okay, for each of the 10 payment are the same, okay? So it's 2,000 for 10 payments, okay? So when we have, okay, a constant payment, $2,000, okay? So this is the time we can call this sequence of cash flows as annuity, okay? So if you have a sequence of cash flows over a period of time, okay, they were paid at a regular time interval, right? In this case, it's annually. So we call this sequence of cash flows annuity, okay? So annuity, there are 2 types of annuity, okay? So let's say this is the timeline. So now, this is now, and this is the year 1, 2, 3, 4, 5. Suppose there are 5 payments, okay? If the payment, it happened at the end of each time interval, okay? So this time interval, okay? If the payment happened at the end, okay, so that's the one. And for this time interval, the payment happened at the end. So if you have the payment happened at the end, okay, and for the same amount, this is called annuity, ordinary annuity. So this is called ordinary annuity. Ordinary annuity, okay? So when the payment happened at the end of the time, each time interval, that's called ordinary annuity, okay? It could happen, right? It could happen, I'm gonna use a different color, okay? I'm gonna use a green. It could happen that the payment happened at the beginning of each time interval, okay? So instead of at the end, it could happen at the beginning. Okay. So in this case, that's called annuity due. Annuity due. Okay. And you can see, right? You can see for annuity due, the cash flow comes earlier, right? By one period, right? Comes earlier by one period. Okay, so this is very important concepts, right? This is very important fundamental concepts. So let me show your hand. Give me a thumb up if you understand this concept, the difference between ordinary annuity versus annuity due. This is important. So give me a thumb up. 1, 2, 3, please. So only 3 students give me a thumb up. So for the rest of that, does this make sense? Do you see the difference between an ordinary annuity versus annuity due? Okay, 2 more, 5. Okay, so this is important, right? If you don't understand this, then in the future, when we do calculations, we have to make a judgment whether it's annuity, ordinary annuity, or it's annuity due, right? And that make a difference in terms of calculation. So make sure you understand the difference, the concept difference, okay? Okay, so in this case, let's see, just give me 1 second. Let's do the basic calculation, okay? So right now, I'm not gonna use any formulas. I'm going to use the very basic idea of this present value, okay? So the idea is for this $2,000 in 3 years, what is that value to present? Okay. So that would be, and you know that, right? It has to be discounted by 3 years. So 2,000 divided by 1 plus the interest rate. That's the 0.05. And this is how many years? See, 1 year, 2 year, and 3 year, right? So I have to discount this number by 3 years. Okay, does that make sense? Okay, let me see. Does this make sense? 1, 2, 3. So I'm discounting the cash flow at year 3 to present. I have discounted to see what's the value for that $2,000 in the current value, the present value. Okay. So for the same idea, okay, just give me a second. Okay. So now for the next one, for this one, so I also need to discount it, right, to the present value. So in this time, it's 2,000 divided by 1 plus 0.05 to the power of 4, right? To the power of 4. Because for this cash flow here, at this point, for this cash flow, there are 4 years, right? So 1, 2, 3, 4, right? Okay. So then you just keep going, right? You keep going. And if you want to know the value of the payment, you're going to add up all these discounted numbers, right? Okay. So I'm going to show you what it looked like. So this is what it looked like. Okay. The first cash flow is discounted by 3 years. The second is discounted by 4, and then you keep going. The last one, the 10th payment is discounted by 12 years. Okay, and when you add them up, will be your present value. Okay, now let's see. Does this make sense? 1, 2, 3. So far, what I'm doing makes sense. Okay, yeah, very good, awesome. Okay, so now it's just a matter of calculation, right? You can do this, right? Using your calculator, you can do this. So I'm just I'm just trying to do this at a very fundamental level, the most basic level, right? So then do a little bit of math work. So you notice that you can actually take out a common factor, right? This sum, each item has a common factor. So you can take that out. So this is a common factor. Okay, you take it out, and then you basically simplified each item. Okay, each item contains this factor. Okay, so then after you take this out, okay, each of these items will be simplified. Okay, so you can see that you take it out and you have two brackets, right? Two big bracket like this. And inside the bracket is simplified version of each of the items above. So now you can see this one is just simply to become 1, okay? And this one, the last one, is reduced, right, to power of 9 because you take out this power to 3, right? So now 12 minus 3, you still have a power left, power of 9 left, okay? So all we are trying to do is simplify this calculation. Okay, so now, okay, let's see. Who should I mute? Who should I mute? So, okay, got it. Mute. Okay. So now it's just a matter of to calculate this one, right? Calculate this one. Okay. And this one is very interesting. This one is actually ordinary due. This one is a annuity due. Sorry, this one is annuity due. Okay, and we can mathematically calculate it, and we have a formula for this actually. So now this one comes down, and then the annuity dues formula, the present value of annuity dues formula is like this. Okay, in this case, R is the interest rate, and T is the number of the payment. Okay, T is the number of payment. In this case, we know that T equals 10, and R equals 0.05. Okay, in this case, the constant here is 1, right? C is 1. C is the equal payments. Within the bracket, the simplified sequence, the C is 1 here. That's the 1, right? This is 1 here. That's 1. So now I can calculate this to become 1 plus 0.05 and this formula, and then this equals to $14,007.68. Okay. In the next slide, I'm going to show you how do we figure out this formula, the annuity due formula. Okay, how do we? I believe I have a video. I used actually a video scribe to make a video to explain how we can derive the formulas for annuity due, okay, or ordinary annuity. So on the next slide, I'm going to show you how this works. Okay, so we are trying to solve this, right? This is the sum of the equal payment and discounted, right? Discounted. So we're going to solve this equation. To simplify this, we let 1 divided by 1 plus R equals Q. Okay. So now the top equation become a much simplified version, easier to look at, right? Easier to look at it. So you have 1 plus Q squared plus Q to the power 9 and equals, and I set this to be equals to S. Okay. So this is actually annuity due. Okay. There are 10 payments, and this payment happened at the beginning of the period. Okay. There are 10 payments, and this payment happened at the beginning of the period. Okay, so to solve this problem, we use a trick. We're gonna set up an equation, the ordinary annuity equation, by multiply Q on both sides to this equation. So I'm going to multiply Q on the left side, and I'm going to multiply Q on the right side. So the equation is still balanced when you multiply the same number on both sides. Okay? So then what happened is, so basically you can see that this left side is actually a ordinary annuity. So Q plus Q squared plus Q to the power 3. And then you keep adding, the last term is Q to the power of 10. Okay, and that equals SQ. So this sequence representing the cash flow happened at the end of the period. So this is the ordinary annuity. Okay, so I'm going to show you. Just give me 1 second. Okay, so this is the ordinary. This is the ordinary annuity. Okay. Okay, so now I can calculate S using these two equations. You can see if I use the top equation minus the second equation, what happened is all these terms are canceled out. Okay, they have all these common terms, right? I can just cancel out all these same terms. So what's left on the left side is 1 minus Q to the power 10. And to the right side is S minus QS, right? So S minus QS equals 1 minus Q times S. And now I want to solve S. S equals 1 minus Q to the power 10th divided by 1 minus Q. Okay? So now we're going to bring this into this formula. 1 minus 1 divided by 1 plus R to the power 10th divided by 1 minus 1 over 1 plus R. Okay, so now I can further solve this equation. So if I multiply 1 plus R to the denominator, so multiply 1 plus R to the denominator and also to the numerator and also to denominator. So when I multiply the same number to the denominator and to the numerator, the equation is the same, right? The result is the same. So now I have 1 plus R, okay? And this one becomes 1 minus 1 divided by 1 plus R to the power 10th. And this one is just R, okay? So that's how I got my annuity due. So my annuity due, this is the formula of my annuity due. Okay? Okay, let me see. Does this make sense? 1, 2, 3. Are you following me on this? Okay. 1, 2, 3. 3 students. 4, 5, 6. Good. Good, good. So, okay. So now you know why. At least you know why. Mathematically, you have a formula for annuity, right? For annuity due here. Okay, so I'm gonna get rid of all this. Okay, so now let's solve this one. Okay, so S is the annuity due here. And then the ordinary annuity, okay, the ordinary annuity is just a little bit difference. The only difference is the 1 plus R, okay? So for annuity due, it contains additional factor, the 1 plus R, but for the ordinary annuity, there's no 1 plus R. That's the only difference, okay? The reason for that is that, like I mentioned, right, the present value of annuity due has to be higher than ordinary annuity. Why? Because all the payments are made at the beginning of the period, right? So in that sense that you get a cash flow earlier, so your present value would be higher versus than the ordinary annuity when they get the cash flow at the end of the period, each period. So they have to have a further one more discount factor. That's the 1 plus R, okay? So with this information, right, and then you understand in the first slide why I use this formula, okay? Why I use this formula, and this is how I calculated the result here, okay? 14,000 $7.68. Okay. Hello, Bernally. You had to share with us about your funny stories there.
I'm sorry, it was just so confusing. I mean, the formulas, it's a lot.
Okay, let me put this way, okay? So if this is very confusing, then just use the formula, okay? So I'm not trying to make everyone understand the formula. If you are not able, that's fine. Don't panic, right? I'm not gonna test you in the exams, ask you to show how this formula is derived. But for those students, if you know, that's great, because sometimes, even you forget the formula, you can derive the formula by yourself, okay? But if you don't know, don't worry about it, okay? The formula, yeah, is there, you can always use, but it's always good to know how this formula comes, how you can derive it, right? Okay, so this is only one way. I'm going to show you how to use different ways to do the calculation, okay? Okay, let's use a different method, okay? Let's use a different method. This method, you can use financial calculators, okay? You can use financial calculators. This is probably a much easier solution, but it's always good that you can cross-check, right? You use two methods. Let's say you have enough time in the exam, right? So you calculate using one method, and then you use a second method, right? If you get the same result under two methods, then you have more you feel more comfortable, right? So sometimes if you only use one method, you may plug in the wrong number, right, to your calculator. You may get the wrong number, right? But with two methods, you can double check, right? Give you a more comfort. Yeah. So in this case, let's use cash flow. Okay, let's use cash flow. So what happened is that we have a CF0. What is the CF0? Okay, CF0 means is the cash flow today. CF0 is here. Now, is there any cash flow today? Okay, so in this case, it's zero, right? There's no cash flow today, so it's zero. C01, that's the first cash flow of the first sequence, okay? So I can divide it, this whole cash flow, into three categories. So that's the, this one is now, today, and this is the second category, okay? So the first 2 years, no cash flow is zero, okay? And then starting from year 3, okay, the cash flow is 2,000, right? And for 10 years. Okay? So this is the information we have, and we just need to communicate this information to the financial calculators, okay? And asking them to calculate the net present value for us, okay? So, and what is the long range, right? So this is the long range, okay? So do you have this calculator, right? Can you see? It's so blur. Can you see this calculator? You have this one, right? Okay. So in this case, what you're gonna do is, I want you to follow me on this, okay? So bring your calculator with you. If you're ready, give me a sum up. Okay, if you're ready, give me a sum up, because this sum up disappeared very quickly. Give me raise your hand. if you're ready with your, oh, you almost all ready. Good, good, okay. Okay, good. Now let's do this together. So what you're gonna do is you turn it on, okay? So now you first press the CF button. CF means cash flow. So you press CF button, okay? So that means the cash flow, okay? So now CF0 is the cash flow for today. In this case, there's no cash flow, right? The earliest cash flow is from 3 years from now, right? So for today, there's no cash flow. So you're gonna enter 0, you're gonna press 0, and then press enter. So that's the second button to the left on the top row, the enter button. So you press 0 and then press enter button. Are you with me? Yeah, okay, good. And then there you can see there are 2 arrows on the top row buttons. The third, the fourth to the left, you have an up and down arrow sign button, right? So now you press the downward arrow, okay? And now you need to enter C01, okay, C01. So what is the C01? So this is my first streams of cash flows, even though the cash flow is 0, but this is still considered as my first sequence, okay? So in year 1 and year 2, okay, so the C01 is 0 because I don't receive any cash flows, right, in year 1. So now let's enter 0 and enter, okay? So you entered 0, you assign the 0 to C01, and now you press the downward arrow again, and they ask you to enter for F01. What does F01 mean? F01 means the number of the equal payment, the equal cash flows, right? In this case, year 1, year 2, right? Both 0. So 1, 2, right? So F01 should be 2, 1, 2, right? So you assign 2 and enter, okay? So you are done with the first stream, and then you press the button, downward button. Now you move to the second stream, that's the C02. So for C02, this is the C02 here. Now you can see it's 2000. So let's give a 2000 and then enter. Okay, so now you assign 2000 to C02 and now press the downward button again. And now you need to assign a number to F02. What is F02? So for the second streams, how many cash flows you have? Payment 1 to 10, right? So now you're gonna assign 10 to F02. Okay. Do we have another cash flow stream? No, right? There's no other there's no third streams, right? So we are done here. We don't have to enter anything anymore. So now you press the button NPV, net present value. So this is the second row, the third to the left, okay? NPV. So you press NPV and you see that the screen displays I. They want you to assign a value to I, okay? In our case, I is 5%. So why don't you press 5 and enter? You are assigning 5 to I, okay? And now you use the arrow upward, you press arrow upward, okay? And now the screen displays the NPV, okay? And now you press CPT, compute, okay? This is the left top corner, CPT, okay? And you get the result. Can you tell me what you get? Are you following with me? Hayden, what do you got? Let me see if somebody maybe speak in the chat. Yeah, gold free, that's correct. Okay, $14.0768. If you are following with me with the calculator, okay, can you, if you understand how to use this, can you please give me a sum up? 1, 2, 3. Okay, so Anna, Oriana, and okay, whoa, good. Oh, almost everyone. Thank you, guys. That's great. Okay, so so in this way, we double check, right? We know that actually we get the same result, right? $14.0768. So in the exam, let's say you finish the exam earlier, right? You still have plenty of time. Well, why don't you use a different method, right? To double check, right? So, okay, so are we good with this? 1, 2, 3. Okay, good. Okay. So let's move on to the second question. Okay, so this one is actually an explanation of how to use the cash flow to calculate net present value, right? So you can see that in this case, now is 0, right? So the cash flow for now, this CF0 is 0. And now you have a sequence of cash flow here, even though the cash flow number is 0, but this is a sequence, right? The cash flow payment is equal, and they all equal to 0, right? And so now here, C01 is 0, right? The cash flow is 0. And how many of this? How many of this? And you can see 1, 2 until 39. So F 0, 1 would be 39. Okay. And now you move on to the second stream here, right? The second stream. And then the C02, okay, is 25K. And how many of it? 1, 2, 3, 4, 5. So F02 is 5. Okay. So that's how you actually communicate, right? Break down the information, communicate this timeline structure to the financial calculator, and the financial calculator will be able to understand. Okay. Let's take a look at question 2. A friend wants to borrow money from you. He states that he will pay you $5,000 every 6 months for 4 years, and there are 8 payments. Okay, with the first payment exactly 2 years and 6 months from today. The interest rate is an annual percentage rate of 7% with semi-annual compounding. What is the value of the payment today? So you are calculating the present value, right? So I give you 1 minute. I want you to draw a timeline on your paper. Find the paper, a pencil, draw a timeline on that paper. Okay. So I want you to practice to do that. So I'll give you 1 minute. Let's do it. And then I will show you what my timeline look like. Okay, so you can compare. I'll give you 1 minute. So draw the timeline and then let's compare. If you're done, give me a sum up, okay? If you're done, give me a sum up. So at least I know your progress. Okay, good. We have 2 students done. So I will give you 30 seconds, the rest of you. So I think a lot of these questions, the key is to set up your timeline correctly. And then it's just a matter of how familiar you are with the different formulas, right? Yeah. So the first key important step is to draw the line. If you have a wrong timeline, so you're almost guaranteed to have a wrong result, right? So the first step is really important. Are you done? If you are done, give me a sum up. 1, 2, 3, 4. 5. Okay, so now let's take a look. Okay, let's take a look. This is my picture. Okay, each interval, each time interval, this is 6 months. Okay, because it's a semi-annual compounding, so the interest rate for the semi-annual compounding will use the annual percentage rate divided by 2. So that's the 3.5%. Okay, so you can see that. So this is at this point. So this is year 2, right? This is the end of year 2, and the first payment start with 2 years and 6 months from today, right? So that's here. So this time point, the first payment is 2 years, 1 year, and 2 years and 6 months from today. Okay, and there are 8 payments. So I can draw 8 payment. Okay, is this your kind of your picture? If you have the same picture, 1, 2, 3, tell me if you have the same picture. Oh, good, Bernally, that's great. It's very important. Yeah, Kaden, very good. So this is very important. So now let's see, let's solve this, right? Let's solve this. So basically, what we could do is, okay, what we could do is we're going to make a new ordinary annuity, right? What is ordinary annuity? Ordinary annuity means you have this a sequence of cash flows with equal payment, right? And then the payment happened at the end of the period, okay? So if I take a look at this period, you tell me if I take a look at this time period, you tell me, is this an ordinary annuity? So I highlight the time frame using the purple color, okay? For that time frame, okay? So the 8 payment, okay, the 8 payment, do you think this is the ordinary annuity for that time period? First, are the payment equal? Yes, it's all $5,000. Second, does each payment happen at the end of each time interval? So this first payment, did this first payment happen at the end of the first time interval? Yes, right? This is my first time interval here, and the payment happened at the end, not here. It happened at the end. My second time interval is here, right? And my second payment happened at the end of the second time interval, right? So now can you see this is ordinary due? Sorry, this is ordinary annuity. Okay, 1, 2, 3. Okay, good. So this is ordinary annuity. So now let's use ordinary annuity to calculate the present value. Okay, so now I'm going to calculate what's the value, okay, at this point, right? Because for this time point, this is the starting time, right? For this time frame, I use the big dot highlight the starting point for that time frame. So the ordinary annuity here, I'm going to use the formula, okay? Present value at year 2, right? That's the time. Present value at year 2 is actually an ordinary annuity. I'm going to use that ordinary annuity formula, okay? So C is the payment, which is 5,000. And in this case, there are 8 payments, right? So T equals 8. And the R equals 3.5%, so 0.035, okay? So when I bring all these numbers into this formula, my result is 34,369.78. So that is the that is the value, okay? That is the value at year 2, right? So that's the value of the future cash flows at year 2. But this question is not asking about at year 2. This question is asking about at today, right? At today. So how can I switch this value at year 2 to today? Well, easy, discount it, right? Discounted by 2 years, right? But discounted by actually 4 time intervals, 1, 2, 3, 4. Okay. So to calculate at this point, we're going to use present value for today equals present value at year 2 divided by 1 plus R to the power of 4, because there are 4 time intervals. This is the semi-annually time interval. So now my result is $29,951.28. Okay. If you understand this, give me a sum up. 1, 2, 3. Thank you, Kaden, Berlin, Dante, Anna, Cheryl, Orion, Dante. Yeah, very good. Most of you. Okay, now let's try this. If you don't understand, give me a sum up and tell me where you are confused. Okay, because I want to help you to learn. So if you don't understand, Cheryl.
Can I ask a question?
Sorry, can you say it again, Cheryl?
Can I ask a question?
Yes, please.
I'm just confused about, it says with the first payment exactly 2 years and 6 months from today.
Yeah.
So I'm thinking like the 2 years is 4 and then the 6 months added 6 months, so it should be 5.
Yeah. Okay, so you are saying that the first payment happened at the 5th time interval. That is correct. Yeah, that is correct.
But I'm just confused why we use 4 on the
Yeah,
the interval.
Yeah. Okay. Yeah. So okay, let me think. I want you to think this way. Okay. Let's forget about the first 2 years. Let's just consider a problem like how should I do it? Can you just ignore this part for now? This part? Okay. Just ignore this part, okay? Now, to solve this problem, okay, they want you to know what is the value at this point, right? Right? So now we solve this first. We solve the present value at this point. At this point, we are solving the present value at this point, okay? And we realize that the future cash flow is actually an ordinary annuity. So to our advantage, we are going to use the formula. So we solved at this time point, the value of the future cash flows are 34,370. Does that make sense? Does that first part make sense, Cheryl?
Yes.
Yeah, right? But now in this question, right? In this question, this time point is actually year 2, right? So this point is year 2. So now to know the present value, my second step is to discount the value at year 2, right? And make it to be present value. So the way we do it is that we're going to discount it using this formula, right? The lump sum present value formula. Does that make sense? So it's a two-step thing to solve this problem.
Oh, okay. So you use the power of 4. It's because the payment is always at the end.
I use the power 4 because I need to count it how many time intervals between in the 2 years, right? In this case, it's a semi-annual payment, right? Every 6 months you make a payment. So my setup, my timeline setup, the time interval is every 6 months. So within 2 years, there are going to be 4 6 months, right? So therefore, in this calculation, we use to the power 4.
Oh, okay. Because I was just thinking 2 years and then there's another 6 months.
Well, if this, let's say if this question is like an annual payment, right? If it's annual payment, then when I set up the timeline, my time interval would be based on each year, right? If that's the case, then when you discounted something from year 2, you're going to use power 2. That's correct. Yeah.
Oh, okay. Okay, thank you.
Yeah, no problem. Yeah. Anybody else have a question on this? Everyone is good? Okay. So now let's use the second method. Okay, use the second method. Okay. Now you tell me what is the CF0? Let's use this second method. Can anyone tell me what's the CF0 in this case? What's the cash flow now today? This is hard because I have to check the chat at the same time. It will be much easier if you can just speak. Okay, so it's 0. Yeah, that's correct. So here is 0. Yeah. And now, okay, I have, this is my today, right now. And now I also have this as my first stream. Okay. And the remaining is my second stream. In my first stream, what's my C01?
0.
0, thank you. And what is my F01?
4.
4, yeah, you counted, right? 1, 2, 3, 4, right? So that's 4. Good. So now let's move on to the second stream. What's my C02?
5,000.
Yeah, thank you. 5,000. Who am I speaking? Thank you very much. And how many? What is my F02?
8.
8. Thank you. Who answered my question? I really appreciate that.
Cheryl.
Cheryl, thank you. Yeah. Okay, so now if you do that, and make sure that the R right here is 3.5. So here you're gonna enter this information, and then you press NPV, and you assign 3.5 to I. Okay. And now you compute NPV, and you get the same result. Okay, you get the same result. So why don't you try it now? I give you 1 minute to use your calculator, see if you can get the result. How do you clear all the saved numbers in the calculator? Does anyone know how to clear all the saved numbers? So I think your question is like under the CF, the cash flow, whatever you did last time, they remain the same, they stay but this time you don't have to clear it. You can just enter a new number and then press enter. So then the new number will be assigned to that parameter. So you don't have to clear it. You can just second and press reset. Okay, thank you. So once you are done, please give me a sum up so I know I can monitor your progress, right? Oh, thank you, Bernie. Did you get the same result? Bernalyn, you get the same result? And Anna, you guys get the same result?
Yes.
Okay, good. Awesome, Godfrey. Oh, awesome. And Keaton, good. So 20 more seconds, 20 more seconds. Okay, so if you don't know how to do this, make sure you practice, right? Make sure you practice. There are a lot of online informations, right? There are YouTube videos, right? If you don't know how to use these calculators, you just Google, and there are a lot of YouTube videos to show you. And actually, they did a better job. They even have the in the video, they even have the picture of that calculator. They show you where to press the button, right? And the sequence. So if you are not comfortable, make sure you do a little bit of homework, okay? So it's good. If you use the two methods, you get the same result. You are fairly comfortable, right? You are fairly comfortable. Okay. So let's take a look at question 3. So question 3, just give me a second. So question 3 is your grandparents would like to establish a trust fund that will pay you and your heirs $50,000 per year forever. Wow, that's great, forever. With the first payment 2 years from today. If the trust fund earns an annual return of 4%, how much must your grandparents deposit today? Okay, so think about that. So you need to deposit some money, okay, and then that money is big enough to sustain this perpetuity, right? Perpetuity, $50,000 per year forever, right? So the idea is you want to calculate what's the present value of the perpetuity, right? So $50,000 first payment 2 years from now, and annual return 4%, and the perpetuity, right? Calculate that present value, and that's how much your parents should deposit today. So this should be an easier timeline, right? So this is what I draw. Okay, so this is today, now, and you won't receive the $50,000 until 2 years later. So that's the first cash flow, 50,000. And for perpetuity, it's just keep going, right? So I just use all this like dashed line here representing this is keep going. Right? So what we want to do is we want to figure out the present value of this cash flows, right? So if I take a look at this time frame starting from year 1 and goes forever, okay, I can easily calculate the present value for year 1 using the perpetuity formula, right? Using the perpetuity formula. So what is that? So at year 1, at this time point, the red dot point, okay, the ordinary annuity formula is simplified. Okay, so simplified to be the formula for the perpetuity. So C is the cash flow payment, 50,000, and 1 divided by R is 4%, 0.04. So I calculate actually at year 1, okay, this perpetuity, the value, if you discount all the future cash flows to year 1, that is 1.25 million. Okay, but this question is asking about now, not year 1. So I know year 1 is 1.25 million. I just need to discount by 1 more year. So why discount it for 1 year? Sorry, just give me 1 second. Oh, it's hard to grab this. Okay. So I just need to discount this value we calculated at year 1 by 1 year. Okay, and I figured out the present value of that future cash flow should be 1.2 million. Okay, and that's how much the grandparents should deposit. Okay, does this make sense? Okay, 1, 2, 3. Does this make sense? Okay, good. If this doesn't make sense, do you have any questions? Please raise your hand. Anybody have any questions about this? Cheryl, I'm not sure if that hand is a Lexi hand or if you have a question. Anyone have any question? No? Okay. So let's use the second method, okay? Let's use the second method. Okay, let's see. Okay. So in the second method, here CF0 is 0. C01 is 0, and there is only 1. So this one equals 1, right? For the second, C02, that's 50,000. But how many payment? Now we are in trouble, right? This is perpetuity forever. Like this $50,000 goes forever. So what is the F02? Which number I should put? Well, my suggestion for calculation purpose, you can just put in 1,000. Just choose a big number, right? Your result will be close enough, okay? Your result will be close enough. You just put a very, very large number here. Let's say use 1,000, okay? And then you calculate the result is actually the same as the way we calculated using the formula, okay? Any questions here? Do you understand everything? Give me a sum up. Okay, very good. Okay, awesome. Okay, let's move on to the question 4. Oops. So question 4, we have question goes like this. You have just leased a car that has monthly payment of $200 for the next 2 years with the first payment due today. First payment due today. What does this mean? With the first payment due today. What does this mean? What are you thinking of when you see this these words in the question? Anyone? Yes, yes, very good, Dante. It's annuity due, right? Because the first payment is due today, So the first payment it happened at the beginning, at the very beginning. Okay. Okay, so then if the APR is 6% compounded monthly. So for monthly, 6 divided by 12, so that will be my 0.5, right, percent. What is the value of the payment today? Again, this is present value. So again, I have to draw this timeline, okay? So you can see now, right, there's the first payment, okay? And then in terms of the months, right, you have 1 up to 24 months, right? Now we should calculate this using a formula. So we're going to use annuity due formula, right? Because the first maintenance due today. Annuity due, right? We are focusing here. Annuity due, the formula is like this. So C is the payment, which is 200, and the percentage, right? Because it's monthly. You use the annual 6% divided by 12 months. So it's 0.5% for each month. So 1 plus 0.005. And T is the number of payment for 2 years monthly. So you have 24 payment. So that's the power of 24. And you figured out the value of the payment is $4,535.14. Okay, so this is annuity due. Okay. Now, do I have a different method? So method 2. So for method 2, can anyone tell me what is, so how many streams do I have? The first, what's my CF0? What's my CF0? Can anyone tell me? 200, great. Okay, and now my first stream cash flows. This is all my first stream, right? What is my C01? What's my C01? Anyone? What is my C01? 200, yes. Again, here, this one is 200. What is my F01? What is my F01? F01 is 2 years. But we need months, right? We need months. Yes, 24. Okay. Yeah. Now, what about C02? Do we care? We don't have a second stream, right? So C02, everything we don't know. We don't even need to enter anything here, right? So it's not, yes. So when you use method 2, make sure that you enter, sorry, 23, my bad. CF1 here, this is really important. Sorry, my bad. Here should be C01 should be 23. Why? You count it, right? If you counted it, so in total is 24, but for today you made one payment. So whatever left is 23, right? So this is, you have to be really careful here. It could be a place that we easily can make a mistake, okay? Okay, so, and then the result, we calculate the result is the same, 45.35, 14 cents. Okay. Do we have any questions on this question, on this problem? 1, 2, 3, any questions? If you understand this question, the 2 method, please give me a thumb up. 1, 2, 3. Very good. Yeah, awesome. Thank you. Do you have any question if you don't understand? Okay, no. Okay, we'll move on to the next one. The last question. So in this question, you have decided to buy a car cost $30,000. Since you do not have a big down payment, the lender offers you a loan with the APR of 12% compounded monthly for 5 years with the first monthly payment due today. What is the amount of your loan payment? Right? So in this case, you know the present value. The car is worth of $30,000. You don't have any down payment, so you need to get a loan of $30,000, right? So that's the present value of your future payment. And the first payment is due today. So that's a annuity due, right? So my annuity dues formula, right? This is the annuity dues formula. So my present value is the value of the car, right? 30,000. And I want to know the payment, equal payment C. And this is the compounded monthly. So I knew is 12, compounded monthly divided by 12. So it's 1%, the interest rate. So here I use 0.01, 0.01, 0.01, 0.01. And the number of payment is 5 years. 5 n equals 5 times 12. So that's 60. So here is 60. Okay. So you can see when I set up this equation, the only unknown is C. So when I solve C, C equals $660.73. Okay. Now, is this correct, right? Is this correct? Can you use method 2 to check it out? Can you use method 2 to check, see if C equals $660.73 correct? Okay, so in this case, this is how I would check it, right? So what I did is, well, my CF0 is $660.73. My CO1 is $668.73. My F1 is 59, right? Because the first payment is happening today, and then there are 59 left for the first stream. And the second stream is 0, right? And how many cash flows for that is? So what I used a 1, but I don't think it would make a difference if you use 10 or you use 100. But you cannot use 0, right? Anna, you are asking the question, why is 1? I don't think it makes any difference if you enter 1 or 10 or 100, but you cannot enter 0. If you enter 0, they will tell you there's error, okay? And then make sure I equals 1%, right? And then when I calculate the net present value, I figured it out, it's $30,000.17, okay? So that's the $30,000, right? So that means my calculation is correct, okay? Now, can you use financial calculators to calculate this payment directly? The answer is yes, okay? Now let's see, approach method 3. Method 3, normally, most of the case, we solve problems. Those problems are ordinary annuity, right? So if it's ordinary annuity, you can just use this calculator without any preparation work. But in this case, we know it's annuity due because the first payment is today, right? So when you do annuity due, you have to do a little bit of prep work to tell the calculator that I am going to do a annuity due calculation, okay? So the way how we do it is, please follow me, right? So you first press the second button, right? So the first button to the left on the second row. So you first press the second button, and then you press the payment button, the BGN. And now you press the second button again. And now you press set. So the second to the left on the top row. And now you press second button again. And now you press quit, right? That's the left top corner. Okay. Sorry, just give me a second. What did you see?
Zero.
Zero. But on the screen, did you see on the top of the screen, you see a BGN? So on the very top of the screen, just above zero to the left, did you see BGN, 3 letters?
Yeah.
Beginning, right?
Yes.
So that's the right mode. So when you see BGN, that means now the computer knows the beginning. What the beginning means is the ordinary annuity due, right? So now they know. But after this 3 setup, the computer know, the calculator know that it's BGN, the beginning. You are going to do a annuity due. Okay. So now let's enter 60. So you press 60 and then press the button N. Okay. So you assign 60 to N. That's the number of the time intervals. And now let's enter the interest rate. Let's enter 1%. So press 1 and then press the button I/Y. Okay. And the present value we know, that's the 30,000. So enter 30,000 and then press the button PV. And the future value is 0, right? The future value is 0 because, you know, you will pay it off, right? You will pay it off. So you put a 0 and FV, future value. And now you press the button CPT, compute. And then you press PMT, payment. The result is negative 660.72. Did you get this result? So if you get this result, give me a sum up. 1, 2, 3. If you get this result, give me a sum up. Oh, Oriana, sum down. Too bad. Yeah. Okay. So Oriana, what happened? You get a different result?
Yeah, I don't know if I'm doing something wrong, but like when I push second BGN, it just says exit.
Okay. Oh, so you have some issues in the beginning setup, right? Okay.
Yeah, I think so.
That's weird. I don't know. It didn't happen to me, and apparently it didn't happen to the other students. So you turn off the financial calculator, right? And then you turn it on. What do you see on the screen?
Now it's just zeros.
Just 0, nothing else, right?
Right.
Okay. So now try it again. Press the second, and then press PMT, right?
Yeah, it just says end.
End. Oh yeah, that's okay. And then press the second, and press set. And
Okay.
then press second, press quit. So what do you see on the screen?
0.
0, and then on top of 0 to the left a little bit, did you see 3 letters BGN?
Yes.
Correct. So then you set it up.
Oh, okay. So I just set it up wrong.
Yeah, now it's correct. If you don't do this, just if you skipped the first 3 steps here, what happened is you are doing a calculation, you are actually calculating ordinary annuity. So by default, the financial calculators believes that it's an ordinary annuity. Okay. Yeah. Okay, so that's all I can offer. So you can see that I'm using different ways to do the calculation, right? I get the same result. So I'm really comfortable I did this correct. Okay. So do you guys have any questions? If you are happy with all this exercise, give me a sum up. 1, 2, 3. Okay, good, awesome. Godfrey asked the question, why do we need to input C02, F01? We don't need to enter that actually. So if you happened to enter it, you can just enter that way. Yeah, sorry for the confusing. Because in this case, we only have one stream. Okay, so that's all I can offer tonight. I hope it cleared some of the confusion. But if you are still confused, you let me know, okay? I'm gonna stay. If you have a question, you are shy to ask publicly, you stay around. And then we can have a one-on-one conversation, okay? So the class is dismissed. And if you have a question, please stay, okay? I'm gonna stop recording.